Two identical objects start at the same height above level ground, and simultaneously, object A, represented by the first dot, is dropped, and object B, represented by the second dot, is launched horizontally with a speed of 20 meters per second, and we're going to assume that air resistance is negligible. So let's start with the free body diagram for these two objects. So on object A, the first dot, after it has been dropped, the object has a downward gravitational force, and that's it. It hasn't hit a surface yet. There's no more applied force on it. It's only the downward force of gravity. And for object B, the one that is launched horizontally, even though it had a force when it was launched in the horizontal direction, after it has been launched, the only force acting on it is the gravitational force. And since the two objects are identical, as told in the problem, that means that the gravitational force on the object A is the same as the gravitational force on object B, so you should try to draw the gravitational force vectors the same length. Part B. Does object A or object B hit the ground first, or do they hit the ground at the same time? And we're trying to justify this answer without calculations. Now, justifying without calculations, we can still go through and list some variables. We just don't have to do any final calculations with it. So let's look at object A. For object A, it is dropped, so the initial velocity is equal to 0, and the acceleration is equal to, let's just make downward the positive direction. So let's say the acceleration is 10 meters per second squared. And both objects are dropped from the same height. So let's just say the delta y. We don't know what that height is right now. So let's just say it's the same for both objects. And we want to figure out the time it takes to get to the ground. And for object B, the time it takes to get to the ground only depends on the vertical motion. Remember, the horizontal and the vertical motion are separate, so it doesn't matter that this one was launched horizontally. What matters is that in the vertical direction, the initial velocity, we say the initial velocity in the y direction, is equal to 0. If it's launched horizontally, the entire velocity is in the x direction. There's no initial velocity in the y direction. The acceleration is 10 meters per second squared because of gravity. The delta y is going to be the same as the other object, and we're looking for the time. And notice that all of these variables are exactly the same. So if we picked an equation to solve for the time, we'd get the same answer for both of them. So it doesn't matter that one's launched horizontally and one is dropped. The fact matters that both of them have the same initial velocity and they're dropped from the same height, so they have the same time for both objects to hit the ground. All right, part C. Does object A or object B hit the ground with the greatest speed, or do they hit with the same speed? So this one's a little bit different because now we are trying to figure out the speed, which has both an x and a y component to it, if we look at the horizontal and the vertical velocities. So if we just solve for the final velocity for object A and the final velocity in the y direction for object B, these two things would still be the same, since everything else is the same. But the difference is that for object A, the x velocity is equal to 0, since it was just dropped and it wasn't moving horizontally. But for object B, the x velocity when it hits the ground is equal to the same as the initial velocity, which was 20 meters per second. So even though both objects have the same y velocity when they hit the ground, the launched object has a greater x velocity, so the total velocity, which is found by doing the Pythagorean theorem on the x and the y velocities, since they're perpendicular, would actually be greater for object B. And then part D is the calculational part of this question. So if the two objects both started at a height of 5 meters above the ground, let's calculate how far apart they land. Well, object A is just going to go straight down. So all we really care about is how far away object B goes from where it was launched. So let's use what we have in this list so far for object B, and we know that the delta y, which is now given, is 5 meters. And we define downward as the positive direction, so I can make delta y a positive 5 meters. So using this will allow me to figure out how much time it takes to get to the ground. So we want to pick the kinematics equation that has initial velocity, acceleration, the change in position, and the time, and is missing the final velocity. So we want to use delta y equals VOT plus 1/2 AT squared. Let's go through the 3-step process. First step is eliminate anything that's equal to 0. So the VO was 0. Second step is to solve for the unknown variable. In this case is t. So we're going to multiply both sides of the equation by 2 to get rid of that 1/2. Divide both sides by a, and then square rootify the whole thing to get the time. And now let's plug in the numbers. The time it takes the object to reach the ground is 2 times 5 divided by the acceleration, which is 10. That's the square root of 10 over 10, or the square root of 1, which is equal to 1. So it takes exactly 1 second for the object to reach the ground. But we don't care how long it takes, or we do care how long it takes to get to the ground, but what the question is asking is how far away does it go? So now we need to look at the horizontal motion. And remember, for horizontal motion, there's only one equation that you can use because it has constant velocity, and that equation is V equals the change in position over time. And since we're solving for the delta x, the horizontal distance, that's just going to be V times t. And the x velocity was 20, the time was 1, and 20 times 1 tells you that the object will land 20 meters away from object A.